Hello, everybody. Welcome back. Happy Monday. Hope you had a nice weekend. Before I talk about this video on even and odd functions, take a moment to just get our brains right, try to be in the moment while we do this lesson so we can try and keep it up here and not get distracted. And I know how easy it is to get distracted because it's a different environment to work in. So follow along with me if you want to, or just skip ahead in the video when I start writing and you should be fine. All right, so here we go. Think about whatever you use on your brain. Just be aware of it. And then take all that focus onto your breath and just focus, listen to your breath going in and out of your body. All right? Breathe in and out. Again, in and out. And through the nose only, in and out. Good. So hopefully you feel a little bit better. I know I do. Now, before I start here, I just want to say, because it's Monday and I won't see you till Tuesday possibly during Zoom, that make sure you see the update on Schoology, because I appreciate everyone who filled out the feedback form for week 1. And what I learned was that the amount of work that I was providing was way too much work during distance learning. The amount of time you were spending was more than what I was hoping you'd spend. So I have made changes to hopefully allow you to still understand calculus, the new concepts, but also to have time to be able to do well in your other class too, because there is that balance. Now, look at the update on Schoology. There's more information there, but I just want to tell you through this video, if you're watching it, I appreciate the hard work you're doing for me and this class, or for yourself. You really shouldn't be doing it for me. And thank you. Sorry it's been so much. Be patient with me too, as I am trying to also adjust to this and how to best serve you during this distance learning. Okay. So here we go. Let's take some notes, possibly, or follow along with me on how even and odd functions work. So even and odd functions. Now the formal definition, because a lot of you going into college next year, you have to kind of start to understand these formal definitions, is, we'll talk about even first. A function f is even if and only if. Now that's something new for a lot of you. That's outside of this class, but for when you get to college, I want to just expose you to it now. If and only if, it means it's an equality statement, and it works both ways. You know, you can assume the left side of the equal sign and try to get the right. You could assume the right and try to get the left. It works both ways. But again, that's beyond the scope of this class. A function f is even if and only if f of negative x is also equal to f of x. Right? Now, what that means is an even function is symmetric over the y-axis. So it's basically saying here that if you plug in the negative value of an input, so say you plug in -1 when you're used to inputting 1, both of those will give you the same output, right? The output of plugging in 1 will also equal the output of plugging in -1. And that's why it's symmetric over the y-axis. You know, you go to the right, you still got to go up 3. If you go to the left, you're also going to go up 3, that same amount. And a graph of even functions, again, it's symmetric over the y-axis, so there's so many different possibilities, but the most common one is, say, y equals x squared, right? Because at, say, f of 1, you're at 1, and f of -1, you're also equal to 1, right? If you plug in the negative value of the input, you're still at the same output. The second definition here is a function g, just to be different, is odd if and only if f of -x is equal to -f of x. And what this is saying is that's saying that it's rotational symmetry over 180 degrees about the origin. And I don't even know if that makes sense to you, and I'll show you a graph. But what it's saying here is if you plug in a negative value of the input, you get the same output but the negative version of it. So let's look at a graph here and help you understand this. So here's an odd function. In fact, a very simple one is just y equals x. Okay. And notice we'll look at the point like 1, 1. So if I plugged in 1, I got 1. If I plug in negative 1, which is a similar distance away on the opposite side of the y-axis, notice how I get the negative version of the output. So I get the output 1. It's still the same number, but it's the negative version of it. And that's what the formal definition of odd means. And graphically, maybe you see it better, but we want to understand the formal definition for the purposes of the AP exam in college. Now, we're going to do 4 examples together, and I'll try to show you how this works. And this will be like what your classwork will look like today, what I expect of you. And the directions are decide if the following are even, odd, or neither using the formal definition, which is, again, what's over here on the left. So the first one, f of x equals 3x1, that's your function. You want to determine if it's even, odd, or neither. So we're going to plug in its negative input and see what happens. So if I plug in negative x, that just replaces the x. And then we're going to simplify and make sense of it. So then that would make negative 3x minus 1, which, if you look at it, you might be like, what is this? Well, let's see. Negative 3x minus 1, is that the same as f of x? And clearly you can see that's not, right? It's not the same as f of x, because f of x is 3x minus 1, and that's negative 3x minus 1. So it's not even. Is it equal to negative f of x? Well, negative f of x would be negative parentheses 3x minus 1. Right? It's just the negative version of this, which would actually simplify to negative 3x plus 1, which is not this. So this right here, when I plugged in f of negative x, what's this imply? This implies that it's neither. Right? And I actually feel bad. This first example was a little bit more challenging than what I imagined when I created it. But hopefully when we do examples 2, 3, and 4, it'll make more sense. Right? So it's not either, because it did not equal this. All right, example 2. X to the 4th minus 2x. And I'm going to push up so you can just see the examples now. So we're going to plug in g of negative x, and we're going to simplify and see what happens here. All right. So plugging in negative x, we'll have negative 1 to the 4th times x to the 4th plus 2x. And negative 1 raised to an even power will always come out even. So that'll just be positive x to the 4th plus 2x. Okay. Now let's see, is this even or odd? Well, this is not the same as the original, so it's not even. You can see that because it's not equal to g of x. All right, that's x to the 4th minus 2x, that's x to the 4th plus 2x. And it's also not odd because it's not equal to negative x to the 4th minus 2x. Because that, again, odd would mean if you just put a negative, it should equal the negative output of this, which is negative x to the 4th minus 2x. But if you simplified this, you would get negative x to the 4th plus 2x, which is not the same as what we got here. So g of negative x, by getting this, it tells us that this is neither even nor odd. And I guess AP exam-wise, the better reason would say it's neither, since g of negative x is not equal to g of x nor negative g of x. And that's probably a good reasoning there, and the work here follows that up. And I would probably have that same reasoning up here. So since f of negative x is not equal to f of x nor negative f of x. So we got two neithers, however you pronounce that. Maybe there is a certain way to say it. But let's see what happens on examples 3 and 4. So So example 3, we're going to look at h of x equals x to the 6th. So let's plug in negative x and see what happens. We simplify this, we'll have negative 1 to the 6th. X is 6, so we can pull that out. And again, a negative 1 raised to an even power will always come out positive. So h of negative x is actually equal to x to the 6th, which is equal to h of x. That's the same thing. So what's that imply? That implies that h of x is even. Good. Okay. And then the very last one, j of x is x to the 2/3. Let's see what happens when we plug in a negative input. We'll have negative x to the 2/3. And we'll have j of negative x is equal to negative 1 to the 2/3, x to the 2/3. Now remember, power over root. That's what one of the last week's lessons were on. So if I was to rewrite this, this is the same as saying negative 1 to the 2nd power with the 3rd root of that. And then we still have x to the 2/3 there. Right? And if we simplify that, negative 1 to the 2nd power is positive 1. The square root and the cube root of positive 1 is positive 1. So we get 1 x to the 2/3, which is just the same as x to the 2/3, which is equal to j of x. So this also is actually even, since j of negative x equals j of x. All right, let's do another example to get an odd one, because I want to make sure you see at least one odd example. And so far I've been unlucky. Make sure you pause it if you need to see any of this again, because I'm going to turn this paper over. You can see example number 5. Because, oops, I did not give you an example of an odd function. Well, you know what the answer is going to be, but now you'll see the work. So let's say b of x is equal to x to the 3rd, which we know is odd. If you saw that example last week, if you graph it, I mean, you can visually remember that this has a rotational symmetry of 180 degrees over the origin when you graph it. But we need to prove it with the definition, which is what majoring in math is all about. So we have b of negative x would be equal to negative x to the 3rd. b of negative x would equal negative 1 to the 3rd x to the 3rd. b of negative x would equal negative 1 x to the 3rd, which notice that this is the negative value, the negative output value of b of x, right? It's b of x, but negative 1 can be pulled out, which implies that b of x is an odd function. And there you go. So there's an example of an odd function and proving it with the formal definition. I hope those notes help. Sorry we had to go to a 5th example. I kind of didn't think that through when I created those. If you have any questions, make sure you come to office hours, I guess, starting Tuesday or Wednesday, or maybe you can ask someone during the Zoom tomorrow as well. Good luck on this. Bye-bye.